everybody. So in our notes today, we are going to be starting the next part of the notes for this unit. So we split this note packet into two pieces. The first packet that we finished yesterday in class was all about the periodic table. The second note packet that we're starting today, and the last one, by the way, it's only two, is about naming chemicals. All right, so that's kind of, and it is closely related to periodic tables. So it'll make sense in a little bit why we put these two kind of different topics in the same unit, but they are very closely related. Okay, so also just for those of you who like to plan ahead, as of this moment, we are anticipating that your test date is either going to be on Thursday, November 5th or Friday, November 6th, depending on which cohort you are in, okay? I'll post that in Google Classroom too in the stream, just so for those of you who like to plan ahead, you can. That's about 2 weeks, okay? All right, so let's dive right in. First thing we have to do is get some definitions out of the way. So a molecule is the smallest electrically neutral unit of a substance that still has the properties of the substance. Okay, molecules are made up of two or more atoms that act as a unit. So I want to talk about this a little bit because it can be a little bit confusing. We have some examples here. Carbon dioxide, CO2, is made up of one carbon and two oxygen, right? So 3 atoms. So this is a molecule. It is also a compound because it's made up of carbon and oxygen, which are different types of atoms, okay? Same thing with water. Water is H2O. It's made up of 2 hydrogen and 1 oxygen. So it is made up of 3 atoms, 2 hydrogen, 1 oxygen, that are bonded together that have the properties of water. But those 3 atoms are not all the same kind of atom. So it is a molecule and a compound. The term for that is a molecular compound. So molecular compound, in many compounds, 2 or more different atoms combine to form molecules. Now you can also have a molecule of an element, which is this last example here, O2. So O2 is made up of 2 atoms of oxygen bonded together. It's a molecule because it's made up of 2 or more atoms. However, those 2 atoms are both the exact same type. They're both oxygen. So that would be an example of a molecule that is an element. In fact, any of our diatomics, our 7 diatomic elements, if you remember that, nonsensical word Hinkelbroth. So hydrogen, iodine, nitrogen, chlorine, bromine, oxygen, and fluorine, 7 of them. Those are all elements that when they exist in the universe are also molecules because they are made up of pairs, two atoms of the same thing bonded together, okay? So just kind of how those words sort of talk to each other. All right, a little bit of review. Ions. Ions are it's an atom or a group of atoms that has a positive or negative charge. So we've talked about this before, right? An ion, it was I think the last thing we talked about in the last unit. An ion is when you have something that has either gained electrons to become negative or lost electrons to become positive. So when we use the word atom, an atom by definition is electrically neutral, which means that it will have an equal number of protons and electrons, okay? By definition, if we call something an atom, the protons and the electrons are the same. An ion forms when that atom gains, make it negative, and I guess that should probably say or, right? Or loses. I'm going to change that. Why? Because I can. All right, here we go. Or. There, that looks better. An ion forms when an atom gains or loses electrons. There we go. So metals And we know now where the metals are, right? They make up 80% of the periodic table. They cover everything to the left of the staircase line. Metals are going to form positive ions by losing one or more electrons from the outermost energy level. We know this because if you look at your periodic table and you look at any of the metals and you look in the upper right-hand corner at their oxidation state, which is possible charges, they are all positive numbers. Why? Because metals lose electrons. This is known as being a cation, which is an ion with a positive charge. So, and here's an example of it. We have regular old sodium, which is 2-8-1. When it becomes sodium ion, Na+, it loses an electron from the outermost energy level and is now just 2-8. Okay? The radius decreases. You are losing electrons. It literally gets smaller. Okay? All right, moving on. Page 2. Nonmetals. Sorry, guys. There we go. I'm back. All right, nonmetals such as chlorine form negative ions by gaining electrons. Again, if you look at your periodic table, at your nonmetals, which are in the upper right-hand corner, now with some of the nonmetals, you're going to see more than one possible charge. Because, okay, how to explain this? All right, nonmetals typically are going to want to gain electrons. All right, they're trying to get 8 valence electrons, a stable octet, as that's known. There are times, though, when you have more complex molecules where you have a bunch of different types of elements. You have magnesium and oxygen and carbon and sulfur all in the same molecule, where one of your nonmetals might act kind of more like a metal with regard to it's going to lose electrons rather than gain in more complicated molecules, which we'll get to a little bit during this unit, but we'll definitely talk more about later in the year, okay? So there are situations where nonmetals will be positive, but that's not the normal one. The normal setting, like what it prefers, is the top oxidation state, the top possible charge. So if I'm looking at chlorine there, so chlorine, it says, -1, +1, +5, +7, super blurry. So hopefully everyone has their reference tables. You go with the top one, all right? We're going to assume that most of the time chlorine is going to be a -1, okay? All right. When they go negative, this is known as being an anion, which is an ion with a negative charge. We have the example of chlorine, 2-8-7. You're gaining an electron, so now it's 2-8-8. Sorry, there was a bug. I got distracted. My bad. I caught it out of the corner of my, what is it? What is it? Oh, it's a stink bug. Okay. All right, we're fine. Okay, it's just a stink bug. I'll get it later. He shall be my friend. I shall name him Pete. Okay. Ionic compounds. When you have positive cations and negative anions, opposites attract, right? So if you have positive cations and negative anions in the same container, they're going to attract each other. These are known as ionic compounds. Compounds that are composed of cations and anions. So these are usually going to be composed of metal cations, because metals like to be positive, and non-metal cation, or anions, excuse me, non-metal anions, because non-metals tend to be negative. Ionic compounds are electrically neutral. So the total positive charge of the cation has to equal the total negative charge of the anion, okay? Some examples of this. Oh, Pete, where are you going? Oh, he's just flying over there. Okay. Oh, if he lands on me, I'm going to freak out, guys. Okay. It's 6:30 in the morning. I'm literally the only person in the hallway right now, so things get a little weird here. Okay. Lost my train of thought. Sodium, this video is a hot mess. My apologies to everybody right now. All right, so sodium chloride is made up of sodium and chlorine. What that literally means, if you take a look at your periodic table, sodium, Na, if I look at the possible charge on sodium, it's going to be a plus 1. If I look at chlorine, chlorine is going to be a negative. They cancel each other out. If I look at calcium oxide, calcium is Ca, oxide is O. When we talk about lime, we talk about like the mineral lime, not the fruit, okay? So calcium, Ca plus 2, oxygen is O minus 2. Again, they cancel out, okay? Now, what these are that I just wrote down, NaCl, CaO, are what are known as formulas. It's a way of expressing information about composition and the number of atoms in a substance. So compounds are composed of elements chemically combined in a definite ratio. So being able to read a formula, which I think most people are reasonably familiar with. So we have H2O. What does that actually mean? It means there are 2 hydrogen for every 1 oxygen. The subscripted number is referencing the element symbol that is in front of it. If there is no number subscripted, it is implied to be a 1. So we have H2SO4, sulfuric acid. So the 2 goes to the H. The S doesn't have a subscript, which means there's only 1 of them. The 4 goes to the oxygen. Okay. Now, what about if you have parentheses in your formula? Well, parentheses in chemistry work the exact same way parentheses work in math. You are going to distribute. What this literally means, NH4, 3, is that you have 3 NH4s. So NH4, 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 1P, and 4 O's. Okay? That's what that literally means. So when you're trying to figure out how many atoms of each element type there are, you want to distribute this 3 by multiplying it against the existing subscript that's in the NH3. So N, there's 1 of them, times 3 gives me 3 atoms of nitrogen. Hydrogen, there's 4 of them, times 3 gives me 12 atoms of hydrogen. Phosphorus, we have 1, oxygen, we have 4, okay? All right, we will get more practice with that later because this is a huge part of one of the things we have to be able to do is figuring out how many of something there are. Naming ions. Okay, so we know that cations are positive. We know that anions are negative. Wow, I spelled negative wrong way up here. That's better. I think Pete was distracting me. But how do you name ions? It is stupidly easy, okay? Monoatomic ions. So again, the prefix mono means 1. Think monorail at Disney World, where it's a 1-rail train. Monoatomic ion literally translates to 1 atom ions. They consist of a single atom with a positive or negative charge resulting from the loss or gain of electrons. Cations are ions with a positive charge. Okay, here's how you name a cation. You name the element, and then you slap the word ion on the end. I'll give you a minute to process that. That's it. That's all you do. Na plus is sodium ion. Ca plus 2 is calcium ion. Mg plus 2 is magnesium ion. These are anything with a positive charge, okay? That's it. Anion is an ion with a negative charge. Now, with this, there is a slight additional rule. You need to change the ending of the ion, or excuse me, the element name to IDE. So, chlorine becomes chloride ion. Fluorine becomes fluoride ion. Oxygen becomes oxide ion. Nitrogen becomes nitride ion. Okay. Now, elements in group 14, so carbon, silicon, germanium, Yeah, those ones. Typically don't form ions. And then our noble gases, they don't form ions. They're perfectly happy as they are because they already have 8 valence electrons. So you're not going to get an ionic form of neon. Just isn't really a thing. Some of the bigger noble gases like xenon, Xe, we've forced to become ionic, but it's not happy about it. So, all right. Now, our transition metals. Our transition metals on the periodic table are right in this middle valley section between groups 3 through 12. So this center section here, 3 through 12, all of these are transition metals, okay? And one of the defining characteristics of a transition metal is that it can have more than one possible charge. So the charge of the cation formed is determined by the number of electrons lost. So if we all find Fe real quick, which is atomic number 26, you can see that it says Fe plus 2 and Fe plus 3. What that means is that if you have Fe plus 2, 2 electrons have been lost, and Fe plus 3, 3 electrons have been lost. When you have a transition metal with more than one possible state, possible oxidation state, more than one possible charge, when we go to write the ion name, we are going to put in a Roman numeral to denote the charge. So for example, Fe plus 2, something beeped. Fe plus 2 is iron 2 ion. Fe plus 3 is iron 3 ion. Copper 1 ion would be Cu. Also, just as an aside, I was noticing in some work that people were turning in, when you're typing, the toolbar up at the very top, if you go over to that X squared symbol, it's kind of a little bit further than halfway, and click that, in your text box, it will actually superscript. So also the one right next to it, the X with the little 2 would be subscripting. So I'm going to put Cu plus superscripted. Okay. You can put a plus 1. That's fine. Or you can just put a plus. It's implied if it's just the plus sign, it's a plus 1. So Cu plus 2 is copper 2 ion. Lead 2, probably guess where this is going, is going to be Pb, whoop, P lowercase b, superscript that, plus 2. Also, guys, some of you might be wondering, why do some of these have the sign, then the number, then the sign? For the purposes of this class, it does not matter, okay? You might have college professors later in life who are going to be more picky about if it's a charge, it's plus 2. If it's an oxidation state, it's 2 plus. I don't care. I don't care. In the event we actually have a Regents exam at the end of the year, which at this moment we still do, so don't be like spreading gossip that Mrs. Saul is like, you know, spreading the tea. At this moment we still have Regents exams, but on the Regents exam, they don't care. So don't stress yourself out about whether it's plus 2 or 2 plus. If you are super interested in the distinction, let me know and I will share some information with you, but I don't want to go down that rabbit hole because it's not really necessary, okay? Which time are we at? Oh, 18 minutes. Perfect. All right, here's what I'm going to do, guys. I'm going to pause the video for a hot minute so that you can finish filling out this chart. When we come back, we'll go over it briefly, and then we will finish up the rest of the notes for today, okay? All right, see you in a bit. All right, welcome back, everybody. So I finished filling in the rest of the chart, so if you want to take a moment and just compare your answers, there you go. I did also add off to the side here just a refresher on Roman numerals, if that's something that maybe you haven't used in a while, you know, beyond like numbering the Fast and Furious series. So just, you know, those, make sure you know your Roman numerals, because that's a thing that I would say typically, in fact, I can't think of an example where we go over 10. Okay. So there. All right, the last thing then are polyatomic ions. So if you think about the prefix of the word poly, like, you know, polytheistic is probably the most common example maybe you've heard from Global. Poly literally means many, right, or multiple. So a polyatomic ion means a many atom ion. So it is an ion that is made up of more than one atom. So it is composed of more than one atom. Now, these atoms are tightly bound together. They're bonded. They behave as a unit, and that unit carries a charge. So collectively, that group of atoms has either gained an electron or lost an electron. And that gained electron kind of buzzes around all the atoms in the unit. And if it loses electrons, it's not just from one specific atom. It actually is just collectively. You have these 4 atoms that are bonded together. They're supposed to have 53 electrons. Now they only have 52. So that group collectively gets a -1 charge, okay? Now, table E in your reference table. This guy. This is your friend. Say hello. This table gives you all the polyatomic ions you need for this course, okay? Say hello. So these are all the ions that you need. Now, one common thing to kind of notice about polyatomic ions is generally they are going to end in the letters ITE or ATE. That's different than what our monoatomic ions, our anions, we're doing up here. So, for example, chloride, ending in IDE, is a monoatomic ion of chlorine, Cl-. As we'll see in a moment, chlorite, CHLORITE, is a polyatomic ion of ClO2, where that group gets a -1 charge. Chlorate is ClO3 with a -1 charge, okay? So if it ends it, typically, there are some exceptions to this, but typically, if it ends in IDE, it is a monoatomic ion. If it ends in ITE or ATE, it is polyatomic, okay? So just to finish some of these off, SO3 - 2, again, if you look that up, that is sulfite. SO4 - 2 is sulfate. The anion form of just sulfur would be sulfide. NO2- is nitrite. NO3- is nitrate. Nitrogen, the atomic form of nitrogen by itself, monoatomically, would be nitride, okay? Practice makes perfect. Is this confusing? Yeah, it is. The more you do it, the easier this will become, okay? So stick with it. This is definitely one of those things, guys. Don't take a shortcut, okay? Do the practice, because the more you do this, the more you will start to hear. It's like any language, right? The more that you speak the language, the more you can kind of anticipate what it should sound like. Same thing here. These words sound weird because you've probably never used them before. Saying chlorite sounds strange. The more you practice, the easier this is going to become, okay? So this is not a time to be Snapchatting homework with friends where, Susie's doing it all and you're writing it down, okay? That isn't going to help you. Fair warning, naming typically tends to be one of the more difficult units because it's one of those things that you either get it or you didn't put the work in and you don't, okay? I say that not to scare you. I'm not doing that on purpose, but I'm letting you know that this particular unit where we talk about naming is one of the units where people start to kind of get their wake-up call of like, oh, I need to actually do work in here, okay? So just, again, I say that coming from a place of love so that you understand you're going to be getting a lot of practice over the next week. Please put the time in to do it. If you do it, what's the half-buttedly, let's say that, it's not going to go well, okay? If you try and just cram the night before this test, it's not going to go well. This is literally, it's kind of like math class. You just have to practice it, okay? And as always, guys, if you get stuck or you have questions, we're going to be doing a lot of practice in class when I'm going to be walking around. You will be doing some practice at home for this unit. Please reach out, okay? That is everything for this particular video. As always, guys, leave me questions at the end if you have questions, or if you have a comment, or if there is something that you want just further explanation on. Please use that feedback question at the end, okay? I will talk to you soon. Bye.